Hi, I'm Chris Lent, an agriculture specialist with NCAT and the ATRA program. I'm here today to produce a video on how to build a vacuum seeder, a do-it-yourself vacuum seeder, with materials and tools that you can readily find available on your farm and at your local hardware store. We've seen some videos online and some good designs, but we are hoping to clarify some things with this video. So we're going to get started here. Okay, step one is, because of the rounded corners of the tray that the seed plate will have to sit down in, I'm going to create a small template out of cardboard by drawing the rounded corner on the cardboard, eyeing that up, and then I'm going to cut that out with the tin snips and see how it fits. Now that should give me a good template to transfer to the seed plate, so we have rounded corners on the seed plate. Now it's time to mark and cut our seed plate, the piece of aluminum that will be used for seed plate, and that's going to be 20 1/4 by 10 inches. So I'm making my 20 1/4 inch marks here on the long ways. And then I'm going to make my 10-inch marks on the narrow ways here. And this is for the seed trays that we're using, which are a heavy-duty seed tray. Whatever heavy-duty seed tray you're using, you can size this to it so that it fits down inside the seed tray. Now we'll draw a line on our marks. And transfer the rounded corner of our template to the corners of our seed, what will be our seed tray. And we can repeat that on each corner. Time to cut it out. Round each of these corners. There we go. Whatever seed tray you're using to create the dibbler board for, You center it on top of the dibbler, what will be the dibbler, and then come down this center line as a reference mark for marking your board. And these marks will be what create the grid pattern for the holes in the seating tray and for the dibblers themselves. And we want to do along the ends too. The entire process on both ends and both edges of the dibbler board. Okay. Now the next step is to tape the seat plate to the top of the dibbler board. And draw out the grid pattern for the holes, utilizing the reference marks we made on the dibbler board on the sides and edge of the dibbler board. Now, I'm going to use a straight edge to draw our grid pattern using our reference marks. So once you have your grid pattern on your what's going to be your seed plate, you take a 1/16 inch drill bit and drill a hole at each intersection of the two lines for each of your grid patterns here. You want to just go through the metal with and into what's going to be the dibbler board, just to make an indent in the dibbler board far enough to give you an idea of where to nail each of the dibblers later on in another step down the road. So I'm going to drill these now. Okay, so those are our holes drilled, 72 holes for a 72 cell tray. And because any irregularities of drilling these holes got transferred to the dibbler, and these are kind of a matching set now because they're connected, we want to make sure that when we take the seed plate off of the dibbler and install it in the actual vacuum seed tray, that we're using the dibbler and the seed plate in the same direction, so that everything lines up well. And that can be done just by simply making a mark on this outer edge of the dibbler board, saying flip towards you when you're actually utilizing it. I'll write that right on here. And a corresponding mark on the seed plate itself to let you know that you're going to be flipping that towards you as well when it's in use. Okay, and that should be our gauge mark for keeping these lined up when they're actually in use. Okay, the next step is to remove the seed plate from the dibbler board that we taped down there earlier. Now that the holes are drilled, we can take this tape off. We don't need it anymore. And we're going to drop it into one of our 10-20 size trays just to see how far it goes down in. And we'll do this as evenly as we can, so that we can get a measurement. We'll need to measure from the top edge of this tray down to the seed plate rather, in order to get a measurement of how much we need to cut off of the other tray, which we call the insert tray, which is going to drop into this tray to give a little extra support around the perimeter of this seed plate. And we have about 3/4 of an inch. So we know from dropping the seed plate into the tray that it goes down in about 3/4 of an inch. So I'm going to make that mark right on the tray itself. 3/4 of an inch down. That's where we know our seed plate rather is going to hit the inside of this tray. Then I'm going to measure from the bottom of the tray to that mark, which is in this case 1.5 inches, and that'll give me a measurement so I can make a gauge in order for me to make a mark around the outside of our second tray, which is going to become an insert tray. The top of this needs to be cut off, and we need to use that gauge to gauge the height of this tray. Okay, so our measurement was 1.5 inches that we determined from the last step. So I'm going to cut a piece of scrap metal here 1.5 inches, and I'll show you. I'll mark it on each end and draw a line between the two marks with a straight edge. And I'll show you an alternate way to cut this type of metal. Rather than using a tin snips, you can also use a utility knife to cut this fairly clean. Just make sure you have a board or some type of backing behind the metal, and you score it with utility blade right on your line. Alternatively, you could use the straight edge and score along that with your utility knife. But once this is scored, you can bend it away from you. Fold it in half away from you. And when you bring it back to you, it'll start coming off. So there's my 1.5 inch gauge. I can now use that to measure up from the bottom of what will be my insert tray. Just keep this flush with the bottom of the insert tray, and I can make a line along the top, and that'll be the amount of this tray that I'll have to remove in order for it to sit down inside of the other tray. And now that we have a mark all the way around the perimeter of this tray using the metal gauge that we built in the last step, I'm going to show you a technique to cut it out with a pair of tin snips. We can go in on an angle right through the this thick lip of the tray and cut out a triangular wedge so that you can get the snips in on an angle this way, and you'll be able to continue right around the line. Now that you're in against it, you can continue with the tin snips all the way around the line. And you can remove pieces of this as you need to in order to get your hand and the tool into position so that you can cut along the line you need to on this insert tray is what we're building here. Okay, now that we've cut the top off, or the rim off of this tray that's going to be our insert tray, to the gauge line that we had drawn around the outside of it, I can insert that into the other tray just to see how it fits and how it's all going to look. And then we're going to make supports that will sit in the bottom of this and support the bottom of the seed plate once we set that in place. To do that, we can utilize the gauge, the pieces of gauge metal that we used, and I just took those, that gauge piece, and cut it in half into approximately 8-inch pieces. But in order to accommodate for the 1/4 inch ridges on the bottom of the tray, we're going to have to set it in place and make a mark. I'll do it on this side so you can see. We'll make a mark right on the top, right where the top of the insert tray hits that, so that we can take about 1/4 inch off of these. And I'll make a mark on both sides so that we can draw a straight line and cut these down to size. Once those are cut to size, we'll fold them at 90-degree angle and put them in place in the bottom of this tray. And that'll be the next step. Okay, so the supports that I measured and cut from the scrap metal will now bend into an arrow shape like this, and we're going to glue them in place with the construction adhesive on the bottom of this tray so they can support the seed plate when it goes in. And we want the arrow facing in and the legs of this arrow facing towards the outside edge of the tray. So we'll see how I can get some construction adhesive on this. bead on the inside. Put a bead on the outside as well. We'll bend the second one and do the same thing. And if we're thinking ahead of move, we want to make sure that we place these so that they don't interfere with the hose of the vacuum that we're going to be pushing in through a hole, most likely through the back corner of this tray. So you want to leave a channel open there for that vacuum nozzle to be able to push in a few inches. Okay, now the next step would be first to drop the seed plate down on top of these and make sure it's on top of this rim of the inside tray as well to support it. And we're going to put a bead of construction adhesive around the perimeter of this. Like to make sure when I'm using construction adhesive or caulking that I take my finger and level out that bead so it's nice and tight both against the tray and against the metal. Okay, I can wipe my fingers off and we'll set this aside to cure. And for our dibbler board that'll match the seed plate that we created, we're going to use these 22 by 16 wire nuts, and we're going to use a 3D finish nail that's 1.25 inches long and nail these to the dibbler board using the indicator holes that were drilled when we drilled out our seed plate. And the way to do that is get these started right on top of the wire nut. Get your nail started on top of the wire nut and start hammering through. And what you may notice is the metal spring that's inside of these that helps connect wires together will start pushing out sometimes. In that case, you can pull that out. For this one, it just popped right out. If it doesn't pop right out, you can take the claw end of your hammer and catch it and pull it out. That's an effective way of going. And then you're going to hammer these nails down until the point is just coming clear of the bottom of the wire nut. And that's what we start the nail in the hole with. That point of the nail then will start right in the hole, and we'll hammer it home till the nail head is to the top of the wire nut. And then we can move on to the next one. And we're gonna cut here and finish hammering those in. So here's our finished dibbler board. We finished pounding in 72 of the wire nuts. A few of them split along the way, but not enough to make it worth pre-drilling any of them. This is the handy thing about this. This is the side that we did for a 72 tray, cell tray, but you can set up another dibbler board on the opposite side of this to accommodate a different cell tray size. So you get kind of a 2-for-1 out of these. But we're finished up with that now, and we'll move on to getting the vacuum seeder finished. Okay, so we've assembled our vacuum seeder and let the construction adhesive cure. We've let it cure for a full day almost here, and it seems to have done the trick. The next step is to drill a hole in one of the end walls of the vacuum seeder that will accept the nozzle end of the vacuum that we're using. We happen to be using a 2.5 gallon shop vac for this project, and you want to size this hole to the size of your nozzle end of your vacuum hose. Ours happens to be 1 1/8", so we're going to use this 1 1/8" hole saw. You could also probably use a speed bit just as well. If you are using a hole saw, you run them backwards so that it actually doesn't end up catching the plastic too aggressively, and you cut a smoother hole through. So we're going to go ahead and cut our hole. You want to place this hole so that it's convenient for wherever you do your seeding. You'll be able to flip the tray and carry the hose along with it, because you need the hose in there with the vacuum on to hold your seeds in place until you flip it over and shut the vacuum off and release the seeds. So in our case, we're going to choose a back corner on one of the ends here, and I'm going to drill an 1 1/8" hole. And there's our hole. Okay, I've gone ahead, after we drilled our hole in the side, I put the nozzle of the vacuum hose into that hole, and it's a nice tight fit. Now, because of the suction of the vacuum and what that can do to put pressure on this seed tray, on the vacuum seeder, you have to drill several relief holes in the vacuum hose, and I do that right here on the other end of the hose where the nozzle that goes into the vacuum itself. You may have to drill 1, you may have to drill 2 or 3, depending on the size. You can always cover them back up as well with a piece of duct tape if you've drilled one too many. So I'm going to drill 1, and then we'll test it and see if it's pulling too hard on this metal seed plate. If it is, which it still is, we'll drill another 1 or 2, and then we'll get to the right amount to run our seed plate without collapsing it. Maybe 1 more. Okay, that seems to do it. Okay, so now we're ready to test our seeder out. We ended up drilling a few extra relief holes in the nozzle that goes into the vacuum in order to get the vacuum pressure down low enough to be okay for the seeder. You could also use a smaller vacuum. A 1 gallon vacuum would do the same thing. So now I'm going to use the dibbler to make my holes in the top of each of the cells on the tray. You just center it over the top and make sure you're flipping it towards you, that those markings that we made earlier on really come into play here. So you're flipping the dibbler towards you where you have it marked and getting it centered on the tray, eye up the center, and then give it a good push down. And there we have, our holes are made. Now we'll go ahead and put the seed in the seeder and see how it works. Okay, now we're going to test the seeder. I'm going to use a pelletized lettuce seed, and I'd recommend if you are planting lettuce to use a pelletized seed, or you could seed raw seed that's larger and rounded type seeds. You could seed as raw seed, but if you're doing lettuce, I would recommend the pelletized. So we're going to pour the seed on top of the seed plate, turn the vacuum on, and I'll jostle it around till each hole has a seed on it, and then I'll invert it, paying attention to my markings of which side should be towards me, and shut the vacuum off, and we'll see how it does. Tap to make sure they've all dropped out. And there we go. We have a seeded tray.